When Voyager 1 launched on September 5, 1977, it was supposed to be a short mission. A modest journey to study Jupiter, Saturn, and a few of their moons. But what happened next, no one could have predicted. Nearly 5 decades later, this quiet traveler has become the most distant human object in space. Now more than 24.8 billion kilometers from the Sun, it continues onward. What started as a spacecraft is now a trailblazer beyond the edge of our solar system. It's the source. Not a giant black hole or distant merger. But a seemingly routine supernova. Except it wasn't routine at all. It unleashed a narrow, focused jet of energy, defying everything science expected. It bent the rules of physics, challenging how we understand star death. But the spacecraft's surprises didn't begin there. Earlier, as it approached the edge of the Sun's magnetic reach, the heliosphere, it found something unexpected. A vast magnetic barrier, a kind of invisible wall. It protected us from deep space radiation, but it wasn't calm. Voyager 1's crossing was wild, full of turbulence and magnetic chaos. Years later, Voyager 2 crossed the same boundary. But that time, it was smooth, quiet, and steady. Why the difference? It turns out, the heliosphere breathes, it expands and contracts with the Sun's activity. Like a living bubble at the edge of our system. And beyond it, space behaves very differently. Crossing the heliopause, Voyager 1 expected a sharp boundary. But it found a strange blend, where our Sun's influence mixes with interstellar forces. Even stranger, the magnetic field beyond seemed to match the Sun's. A coincidence? Or a clue to a deeper, hidden connection? In this borderland, Voyager detected plasma waves, magnetic tension, and a strange dance of cosmic radiation. It also found pockets, areas where plasma was thicker, denser, more active. Far from empty, space out there is full of structure. It's alive with motion and hidden patterns. Then came whispers from the ancient past. Voyager began hearing echoes, low-frequency shockwaves from long-dead stars. These were supernova blasts from millions, or billions, of years ago. Their power still ripples through the galaxy. They were stronger, more energetic than models expected. Are they clues to how galaxies form? Or how solar systems like ours begin? Voyager also found plasma oscillations, waves in the interstellar medium. These waves help measure density directly. They showed that interstellar space isn't still, it moves, shifts, and pulses. Are these vibrations from ancient cataclysms? Or signs of unknown forces still at work? And then, there's the jet. That narrow gamma-ray beam. Its radio signals were strange. Its X-rays were different. Its pattern across the spectrum was something we've never seen before. Could it be a new kind of star collapse? Or a phenomenon we don't yet understand? Voyager brought us back to the magnetic wall. It shifts. It breathes. It pulses. What if it breaks down? What might cross over? On September 5, 1977, a small spacecraft lifted off from Earth, carrying with it a gold-plated record meant to speak for all of humanity. Originally built for a short mission to explore Jupiter and Saturn, Voyager 1 went far beyond what anyone expected. Today, it drifts silently at the edge of our solar system, venturing into the unknown void between stars. Almost 50 years later, it still sends signals from over 24.8 billion kilometers away, farther than any human-made object has ever traveled. But Voyager's purpose has transformed. It's no longer just a scientific mission. It has become our eye into the deepest parts of space, and a question flung into the dark. In October 2022, Voyager 1 detected something extraordinary, a massive flash of gamma rays bursting from deep space. Astronomers called it BOAT, short for Brightest of all time, a nickname that captured its raw, staggering power. This blast was so powerful that it disturbed Earth's upper atmosphere, even though it happened billions of light years away. Surprisingly, the source wasn't an unusual cosmic event, but a regular supernova, the kind we've seen before. Yet this one was different. It unleashed a narrow, focused jet of radiation across many wavelengths, breaking our current understanding of such explosions. It wasn't just bright. It was strange. It hinted at unknown physics behind what should have been a familiar cosmic event. Was this the death of a star unlike any we've known? Or a rare type of blast that hides in plain sight? Years before the gamma-ray flash, Voyager 1 crossed a legendary boundary, the heliopause. This is the edge where the solar wind, blowing from our sun, gives way to the interstellar wind beyond. But Voyager found more than just a crossing point. It discovered what scientists now call a magnetic wall. This region was turbulent, constantly shifting, and rich with magnetic energy where the sun's influence ends and the galaxy's begins. Voyager recorded sudden spikes and drops in magnetic strength, proving that this region isn't still, it's alive. When Voyager 2 crossed the same boundary, it encountered a calmer transition, smoother, thinner, more gentle. That difference changed everything. It suggested our solar bubble isn't solid, but flexible, shaped by solar cycles and interstellar pressure. The heliosphere, once thought of as a shield, is now seen as a living, breathing structure. As Voyager moved past the heliopause, the surprises didn't stop. Instead of leaving the solar system's influence behind completely, it found that the sun's magnetic field still echoed into interstellar space. Even stranger, magnetic fields from the galaxy beyond appeared to align with the sun's field, something our models never predicted. This unexpected harmony means the edge of our solar system might be a blending zone, not a border. Here, solar and galactic forces meet, mix, and reshape each other in ways we don't yet fully understand. It raises new questions. Is our solar system magnetically connected to the rest of the galaxy? Could unseen magnetic currents link us to faraway stars, forming a galactic network we've never